So I usually start the talk with some nice cover just to get all the crowd hypnotized. Is it working? I mean, this is a recording. It would be much cooler if it was actually running in the browser, but it's a GIF. Okay, so I'm going to do a little bit of a warm-up. Who was earlier this year at Angular Europe? Okay, just a couple of us. So that will be perfect. So I'm going to try something with you or together, and this is what I call the Mexican wave. Okay, are you familiar with the Mexican wave? So we are going to start from that corner, and we did this at Angular Europe. It was a disaster. So I'm hoping you are going to beat what we did then. And there's a lot of smart people here. I mean, I'm hoping you can follow through. So we are going to start from that side and do the Mexican wave, which is basically, you go like this, and when you see the person besides you, you just copy it, okay? And I'm going to add a twist because I have so much, trust in your skills that we are going to try the slow motion Mexican wave. This is exactly the same, but a little bit slower. And it's a good fit for the talk as well, okay? So we are going to start from that side. When I give you the order, you start, and then you do the Mexican way, but not at regular speed. Slow it down, okay? So I'm going to start like also in slow motion, like, okay, here we go. You start. Yeah, very good, very good. Oh my God, so lazy. Come on, give all. You can do it. My God, look at the faces. That's terrible. Okay. They told me. I mean, you're going to do a talk in France. It's going to be hard. So yeah, it's true. You probably haven't got enough cheese during lunch, so you're not at your best. Happier. So here, the talk for today is a little bit funky, bending time with the schedulers and RxJS. So how many of you are already familiar with RxJS? Okay, you probably know nothing at this point. So I'm going to go a little bit deeper, and this is a topic, an area which is not so much covered. So I hope you will enjoy it. I'm going to start introducing myself. So I'm Gerard Sans, Google developer expert. I'm not actually French. I know that my name is very French. A lot of people either tell me that I'm from France or I'm a font. I'm not a font, okay? I'm just a human being. So Google developer expert. I mean, there are few Google developers experts, if you can believe that. There's a big community here in Paris. And if you meet someone that is a Google developer expert, or GDE, it's basically someone that is very active in the community. So probably you can learn a lot from them. You can follow them on social media, get the blog posts, what they are working on. And we don't work for Google. Some people try to befriend us to send a CV or something like this. I mean, it doesn't work like this. We don't even work for Google. I mean, if I could, I just did it. So it's sad. I don't work for Google. 2 years ago, I started doing talks full-time. So that's been a long ride. And started in Europe, then moved into US and some other places. Maybe you can see there. I mean, this is part of the talk. Sorry. And you can see here, yes, I was in Japan. It was Angular Japan. I'm basically an Angular expert. So here are some of my blogs. If you like some of the topics that I cover, you probably will find a blog post covering it with a little bit more detail. I also run a couple of communities in London. This is Angular Zone. And recently I created a new community. This is GraphQL London. GraphQL is a new technology from Facebook that is supposed to be the new generation of REST APIs, kind of. I'm also a trainer. In this picture, maybe you recognize Todd Moto is not an attendee. He was a volunteer. And most of the time was on Twitter, so it wasn't that helpful. Just last year, I started doing Master of Ceremonies. So maybe if you were at Angular Europe, you may see me there. I did also React Europe, which maybe is a little bit shocking, but it's also fun. I'm kind of everywhere. And this was a funny side project that I did with the guys of Reactive Conf. And this was 4 days doing one talk every day until we went from Bratislava to Prague. So that's some of the things that I do. What else? Okay, let's talk about ngCruise. I mean, I know you want to know about this. So here is a conference where you go into a cruise, a regular cruise, and depart from Miami and go around the Bahamas for a week. Maybe you are in the wrong conference. Yes. Yes. You can see, I mean, this is not Photoshop. This is for real. This happened last year. And look at the venue. I mean, it's not a crypt. I mean, what is this? So let's start now with the talk. I'm going to speed up. Sorry for the long intro. You know, all of this self-promotion is good. And so what? I mean, we were going to talk schedulers, but then I realized, I mean, if I go straight to the topic, you will probably miss all the talk. So I'm going to stop with the event loop. And this is important because how you schedule tasks in the browser has some specific, specific behaviors that you want to know about. So this is a small test. I'm going to do a test on you. I'm going to put, some pressure back to you. And this code, if you can follow, is a simple code. So I just define some functions. I have the lock rewriting. It's just because I'm a lazy developer. And here I define what I call macro. And macro is just using set timeout. So this is an arrow function, and it's just taking the argument and using that and console logging that on the console. So that's basically just delaying this execution to the next tick in the browser. The next function is a little bit different, and it's using a promise that will immediately resolve. And then it will do exactly the same. It will console log the value in the console. So we have this code now. We have a call to console log, then macro, and then micro. We are passing some arguments. The sequence here is log1, macro2, micro3, and log4. And I'm going to ask you to think about the answer. What do you think is the answer here? Okay, it doesn't matter. Fail. You probably, I'm going to guess that you didn't know. But wait for it. So it's C. And this is maybe surprising some of you, and this is an opportunity to learn. So let's explore why that happened. And one answer to that question is that actually, the event loop is going to wait for microtasks. And this is the task that are using promises. So every time that you are using promises, anything that is happening in that context is going to execute before the event loop kicks in, which is an interesting learning. What I have prepared, if you don't trust me somehow, I have this little demo, which is a small environment where you can run code and see how it behaves in the browser. So I'm going to run this. I have a little setup. It's just the same code. You can see it here, and then the functions definitions. I cannot use arrow functions, just the ECMAScript 5 functions. So let's see how that runs. So we can see here the first call is just calling log1. So that's going to call this wrapper and then console log. That's going to write in the console the value 1. Let's keep the execution. Now we get this macro with argument 2 that's going to call this set timeout. And one thing that happens, which is interesting, is in this case, I use set timeout with no arguments. That's going to use a delay of 0. And that puts set timeout in this stack that we can see on the right side. And that's going to put this immediately, because it has no delay, on the queue, on the callback queue in this diagram. And so far, so good. Now we got to the third call. This is a micro with argument 3. And that's now going to use this other function, which is calling this new promise that it's immediately resolving with that value. This is the code that we can see on the call stack. And we go now for the next call. So that didn't execute. That didn't left any console log messages. So now we are going for the last instruction. This is log with value 4. And this is going to execute synchronously. So if you see, now we have the values 1 and 4. And what will happen now is, this is maybe why you didn't answer correctly before. So now what kicks in is, if you see the code here, the syntax is highlighted. This is the microcode. This is the promise now executing before the set timeout that we called with the macro call. So that's going to change the order. And then finally, we got the execution. If you see now, it has run out of instructions to run. It went into the queue, pick up the set timeout that had a console log inside, and now it's the moment when we get the final value. So actually, the sequence is 1, 4, 3, and 2. And this is important because that means two things. That any code that is running is going to execute before the APIs that are in the queue, in the event loop, and everything that it happens within the context of a promise is going to take precedence and be executing before that. That can also mean that it can stall execution. So you may think that something is going to execute after some delay, but actually needs to wait for you are still working on. So these are few behaviors that you may or may not know. So this is what I call JavaScript call maybe. When you are calling set timeout and you are setting some expectations, like for example, when we call set timeout without arguments, that means that it's going to pass a delay of 0. That's actually not when it's going to be executed. It's going to be on the event loop, waiting for the time where no other processing is happening. Let's try some more exercises. So here I'm using set timeout, and that's going to be on this site web APIs calls and going into the event loop. So let's play with this a little bit. So we have here 2 calls with the same, that's exactly the same code. If we don't call it with an argument, it's going to be using 0 as a delay. And then the last one is using console log. So now, what do you think is going to be the answer? Okay, you're making me some signs. First row is sleeping. Okay. So, yes, it's the last one. Very good. You are progressing now. I'm very proud of you. So let's go with a little bit more difficulty, slowly. So now I'm using set timeout and changing the delays. First, we use delay 0. Which will just put the set timeout on the web APIs and then just go straight to the event loop. But now I have some delays. So that's going to be having some time, some rest on that side queue. And then after this delay it's expired, then it will move this into the event loop. So now we have these 3 different calls with different delays. What do you think is going to be the answer? Okay, you are struggling. Some people is making notes. Well, the answer is that you fail. I'm going to assume that you didn't know, but actually it's going to be B. Aha. Aha. That's a disaster. I mean, JavaScript people, come on. We can do better. So the thing here is you put these set timeouts like very quick. This code executed maybe in 2-3 milliseconds. So we have now all of these instructions waiting to get in. The longest wait is 3 seconds. So at that time, everybody is going to be in the event loop waiting for execution. And because it's a console log, it's going to execute maybe in 1-2 milliseconds. So that's going to be approximately 3 seconds. Very good. Next thing that I want to show you is how loosey is the browser when trying to set repetitive tasks. So here, imagine we have this task, this code that we want to execute every 50 milliseconds. And so far, so good. We have a task that is actually smaller than this time frame. So that's going to look pretty much like this. So everything is working fine. You are happy. Everything works as you expected. But let's imagine we are using set interval, but we got into some trouble. The actual code is taking more time than the actual time that we want to wait. So in the reality, we get something like this. The task is taking too long, and that's going to produce this effect. It's going to shift the tasks that are coming later, and it's going to be unsync. Of course, there's some examples when these can be really bad. So imagine I was talking with Alisa before this talk, and I was thinking of an example. And one example would be like playing some sound. Imagine you are playing some sound every half a second, something like beep, 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 beep. If you get a delay, you basically change the melody. You change, the output is beep, 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 beep. So that's not exactly what you planned for. So the browser is not really that easy when it comes to asynchronous code. So these are some of the abstractions that we can use. I've shown you how to use set interval. Before I shown you how to use set timeout. And this is not very good behavior. So one thing that you need to understand is that the delay that you use with these two APIs is just the time that it will wait on that queue. It's not going to be executed at that time, unless, if there's no other things that the browser is busy, it's not going to be able to follow that plan that you instructed with that argument. So this is some of the warm-up to the talk. We haven't started yet with the talk. So who can help us? It's quite a difficult environment to work with. So RxJS can help us. And RxJS, this is RxJS 6. I don't know if you know these operators by heart, but I just took them from the source code in GitHub. These are actually 103 operators. It's quite a lot of operators there. I'm going to show you some of them that are synchronous by default. Let's start with the easy ones. So these ones are, for example, off, from, and range. Maybe you have used these operators, and they are using, as a default, a scheduler. They are using the queue, what is called the queue scheduler. And we are going to cover that in more detail. The next type of operators I want to cover is the asynchronous ones. And asynchronous by default, this will be, for example, of course, timer and interval. These are using set timeout and set interval behind the scenes. This is using Async Scheduler, so that will give us the same behavior that we have seen with both set timeout and set interval. Actually, there's one implementation detail, which is RxJS is not using set timeout because that would require some actual sync code. Because what I showed you, the slides that I showed you before, if some work cannot execute at the time that you plan, that's going to stack the delay. Imagine you have something that is running very frequently, that's going to be a disaster. After 3-4 seconds, that's going to be too much, and it's going to be far away from the plan that you set at the beginning. Set interval actually is trying to sync that automatically for you. So the browser is trying, if something gets off sync, is trying in the next executions, is trying to make that sync work for you. And that's going to perform much better than if you try to do that with JavaScript. So it's using set interval internally. And this is how you can change the behavior. So one of the benefits of using RxJS is that we can switch the behavior. And the way we do it is by using extra arguments. So here we have this little code. We have off that's going to be creating an observable that will immediately emit the value 1. And then we subscribe, we console log that, and then we log the value 2. So that's going to come back with 1 and 2. If we wanted to change that behavior, which is synchronous, we want that to behave asynchronously, we can introduce the Async Scheduler, and then we can pass that to the operator so it will use that scheduler from that moment onwards. So that will just reverse that code. This is now behaving more or less like a promise now. So that will console log the value 2, and then it will put this on the event loop in the queue, and then it will run that code. If you see, we haven't changed the observable, which is quite powerful. We haven't changed the actual implementation of the observable. We just said, use this other scheduler. So whenever you are using an operator, there's this rule that the RxJS team is using, which is called the least concurrency principle. That means that in any case, when you're using an operator, it's going to try to use the least concurrency one. And if you think about it, that's always going to be sync code. So that's why the default in most cases is the queue. So if you are not sure, it's probably going to behave synchronously, which is kind of counterintuitive because a lot of the time we talk about RxJS in an asynchronous context. At this moment, I want to cover some new features of RxJS 6. I mean, it's a big release that just happened a few weeks ago. So I'm going to show what's in there so you are up to date. And there are a few things in there. So we have what is called the friendly imports. Now you just need to remember these two barrels, so these RxJS and RxJS operators, and we can get our imports, so it's just really easy to remember. Then we have some changes, and this may surprise you because it will introduce some changes in the syntax. And the reasoning behind is that RxJS wants to be ECMAScript compliant. So that introduces the pipeable operators that makes operators pure functions. So you can implement operators much easily. There's also some problems. We cannot use some keywords which are being used by ECMAScript, and I'll show you some of them. And then they also simplified the API. Before this release, there were 120 operators. Now we are almost around 100. So there have been few improvements here. So what are the operators that change name? Well, the list is small. We have these operators, and they have changed to these equivalents. So do now is stop. This is to introduce side effects. Throw, of course, this is a keyword in ECMAScript. So now we need to change it to throw error. Switch is moving to switch all. And finally is called finalize. So I'm going to show a few examples so you can see how that looks. Here we can see the new imports, the friendly imports coming either from RxJS or RxJS operators. That's much easier than what we got before. This is just an example showing how we would filter a list of numbers. So interval is creating the numbers 0, 1, 2, 3. That's the sequence that you can see at the bottom. And running this function together with the operator filter is going to produce the output at the bottom. One thing that we can start seeing is also the use of pipe. And now we are not using carrying. We are not carrying the functions. We don't use the dot notation for the operators. We use the pipe, and that will chain the operators for us. So one thing here that I want to ask you, how many observables are here? Or how many observables can you see? This is kind of a tricky question. Just want to check if you really know RxJS. Who says there's one? Okay, not totally sure. How many of you say that there are two? Okay, nobody, nobody. Everybody's shy. Well, the actual answer is there are two. Observables are immutable, so every time when we call a new operator, we get a new observable back. So actually here there are two. And the two observables that we are showing is the two observables that you can see at the bottom. This is how error handling would work with the new keywords. Just a few examples. Yes, RxJS supports Unicode and emojis. I was very happy when I realized. And here, this is a very easy error handling. So error handling works this way. When there's some error, I can decide to change the behavior of my observable. Here, I'm just sending a text, but you can also change it to behave in other ways. So let's start with some operators that we can use with the schedulers. This is just a quick review. So observable behaves with different APIs. We have next, we have complete, and that will behave like this, emitting these three values and then completing. This is what implementation of that observable will look like. So we can use observable create, call these values, and that will be the execution for this code. When we are using an async implementation, we can naively implement it like this. So now we are using set timeout. That will go into the event loop, and we can also do the same with all of the different events. So that now will execute in a slightly different manner. So that's going to call the next, and then when it gets to the last value, it will go into the complete. So in order to work with the schedulers, we can modify this behavior, as we have seen, passing an argument, but we can also use what is called subscribeOn. This is an operator that will allow us to change the source of our observable. And this is how it works. If you realize here in this diagram, you can see that the top arrow is in blue, and that will execute in the context of the scheduler that I pass as an argument. So this will execute in async scheduler. And that's going to change the behavior for that source events. You can see in this example, I'm using map, so it's just passing the value through, and then I subscribe, so it executes. That will also happen with the complete. It's going to execute asynchronous, it's going to go to the event loop, and then go through these different operators. SubscribeOn will change the source of execution. It will only be used once at the top. We have another alternative, and this is observeOn, and that's going to stack before the actual operator that we want to modify. And in this case, it's going to change the behavior of the next notification. So before it was changing the top events, now it's changing the event after map. That's in blue, which is using any scheduler that we set on the first argument. And in this case, it's going to be async. So observeOn will change the notifications executions. We have these three different notifications, and then we can use it before the operator we want actually to change. Because we are using the browser, I mean, if we're using RxJS in the context of Node, we have more options. We have more, set of schedulers that will change, for example, how the thread is going to execute that task. unfortunately for the browser, we only have a single thread, so there's no much we can do with it. There's basically we can do a change from asynchronous to synchronous, and maybe we can use a slightly different behavior with the queue. So let's see how did you do in this section. So now I'm using subscribeOn with the Async Scheduler, and we have this code calling off with the value 1. That's going to emit the value 1. Then we have a lock with value 2, and I change that with subscribeOn. So what do you think is that going to come out with? Okay, let's see. Yes, you are doing very well, and I'm going to change the image here. You get the thumbs up. I mean, that's really cool. I don't know if you recognize the people in the picture. We have only one of them here the front row. Patrick, I mean, of course, we want Patrick's, acknowledging, like, yeah, well done. So these are some of the schedulers that we can use, and I'm going to go really fast through these schedulers. So we are going to cover the queue scheduler that executes synchronously. It executes the task in order, and actually it will wait for the last task to execute before it continues. So that's exactly behaving more like the promises. This is a little bit dangerous because we can stop the event loop to take effect. So you can actually stall the whatever is in the event loop. These are some examples. So you can see this code, and I hope you can follow it at this point. This is synchronous, so it's going to execute in this way. This is a little bit confusing, maybe. We can also use the queue scheduler with a context. So we are setting this context, and we are getting the execution now slightly different. And now we are going to get 2, 1, and 3. But this is specifically behavior from queue scheduler. A SAP scheduler is going to use the microtasks. So that's going to execute before the event loop. That relies on promises, and that's going to be much more performant than using, for example, set timeout. This is a quick example. So you can see here this code, I'm mixing some set timeouts. That's going to be a macro task, then a SAP scheduler, which is using promises, and queue, which is using synchronous execution. So that's going to come back with this output. And at this point, I think that you are following. I will assume that you are following this code correctly. The Async Scheduler is just the regular scheduler that will use the event loop. So this is using a set interval behind the scenes. The answer to why we are not using set timeout is because we don't want to do the manual sync when it goes off a little bit. And set interval is doing that for us. So you want to be using set interval when you want to repeat, some action over time. This is a little bit less performant, as you know, because it's going to wait for any microtask to execute before, and is also going to use, the event loop, which is taking a little bit more resources. This is another example. So now you can see that this is going to use, in this example, is using the microtask, the microtask, macrotask, and then synchronous code. So that's going to come back with this 3 to 1. We can also use some other APIs to modify this behavior. We get a subscription for any call to a schedule, which is one of the APIs for the scheduler. And then we can just cancel that subscription. So instead of getting 1 to 3, now because I canceled the initial scheduled task with value 1, I'm not going to get that as a result. I just cancel it. So you can also use these low-level APIs for your actual code. The execution is going to be behaving as you expect. So we can use that second example that I show you. This is a little bit delayed. It executes 2 seconds later. And you shouldn't be surprised to see the result. There's a final scheduler that I want to cover, and this is executes asynchronously. This is using the request animation frame, and that's going to behave adapting to the frame rate of the device. So if you're using a mobile phone or a desktop, it's going to adapt. It's also going to slow down if it's not active, if you are not showing that screen. It also takes into account few hardware details, so you can run your animations very performantly. This is how animations work. So you give the browser some instructions, the initial and end state, and it will calculate the intermediate states. So that's quite intense on the CPU. I'm going to show you this video showing these different frame rates. What we target usually for web is 60 frames per second. It's taking a little bit. Okay, that's not going to happen. So frame rates is very close to what we defined at the beginning. We are using this 60 frames per second. If we translate that to milliseconds, it goes between 16.66 milliseconds. That's going to try to paint these different frames that are forming the animation, and is going to, for example, render like a circle, a triangle, and a square. If something happens and we are taking too long to paint a frame, that's going to behave like this. Obviously, the browser cannot have time to render that frame. It's going to use the previous one. So that's going to hold the animation. That's when you see an animation that it holds. And then we just miss one of these figures. An easy implementation using a set interval will look like this. That's going to take the resources from it's ignoring the device frame, so it's going to also run out your batteries. It's going to execute all time. It ignores, this information from hardware. The solution with request animation frame works in a way that you tell the browser, render this for the next cycle. And that will work a little bit better. In a happy path, it will just be able to render this. If there is no time, it will just slightly delay that, so the browser can deal with that delay. So this is exactly the same code. It's very similar to what we saw before. And one thing that we can do then when we use this scheduler is build the animations on our own and use all of these nice features. So this is a simple code that will just rotate, a circle around the screen, and just using, the scheduler from RxJS. So this is the last demo I want to show. It looks more or less like this. I don't know if you can feel the smoothness of this example. I'm just going to just quickly change to async, so you can see how that behaves. This looks a little bit more, you see that there's a lot of frames being lost because it just stops, and it's just the behavior from not using the right API. So that's the wrap up now. So what is a scheduler? It's a data structure, execution context, and also virtual clock. We can change all of these. This is a slide as an overview. Just for reference, you can come to this later. If you need more information about this topic, I have a couple of talks that you can follow. This is covering marble tests and high-order observables. There's also some other videos online that you can follow if you want to know more about observables. Thanks a lot. That's what I wanted to say.